Hello everyone, my name is Raina D. Jute and welcome to my technical demonstration and overview of my Module 9 MERNstack project. Today I'm going to walk through the front-end architecture and implementation of this CodeBloggs website, which was built in collaboration with another teammate who handled the backend. So for context, the backend was already providing endpoints for users, posts, comments, and sessions, so my job was to build out the React application that would consume those APIs and create the user experience that you see here. What I want to show you today is how I structured the front-end architecture, how state management works, the authentication flow, and some of the design decisions I made along the way. I'll take you through the code, show you how the different pieces connect, and demonstrate the features live in the UI. So without further ado, let's dive in. So first thing I want to talk about is the tech stack. This is a React 18 application built with Vite as the build tool. So I'm using a React router for client-side routing, Redux toolkit for global state management, though I'll explain why I kept the Redux minimal and just plain CSS for styling. So there's no Bootstrap, no Material UI, everything is a custom built UI. The folder structure here is pretty straightforward. So we've got a pages directory for all of the route level components like admin, blogs, home, login, etc. Then there's a components directory for all of the reusable UI pieces, things like the header, the like button, the nav bar, and things like that. There's then a store folder for Redux, a utils folder for data normalization helpers, and then a styles folder that houses all of the CSS for the individual components. So first things first, let's take a look at main.jsx. This is the entry point. It's where I'm wrapping the entire app in the Redux provider. This is the only global state provider that I'm using, so there's no context API, just Redux for one specific thing. Then if we take a look at app.jsx, this is basically the brain of the operation. So this is where the authentication happens, the cookie helpers, session validation, login, logout. It's where routing is defined and where I'm managing whether a user is logged in or not. So let's start with the authentication flow. So when the app loads, we're calling validate session in this use effect. So this hits the backend API's session validate endpoint with the session cookie. And if the session is valid, then I populate the current user state and set authenticated to true. You can see that we're using a fetch with credentials include. So the browser automatically includes the HTTP only cookie. If the backend says the session is valid, I normalize the user data and then store it. If not, I clear the cookie and keep the user unauthenticated. And at the top, we have these cookie helpers. So you can see we've got set cookie, we've got delete cookie, because I'm managing session tokens manually. So the backend sets an HTTP only cookie on login, and I need to check if it exists and clear it on logout. So if we flip over to the UI, when a user first visits the app, if they're not authenticated, they will see this login page. So let's log in with a non-admin user really quick. We'll do Etienne's login. When I submit this form, it sends a post request to API/session/login. The backend validates these credentials, creates a session, and then sends back a token to the front end. Then I store the user data, set is authenticated to true, and then the React router automatically redirects to the home page. So let's log in. And this is the home page, and you can see this global alert right behind me saying welcome back. And this is the full layout. So we've got the header at the top, the nav bar on the left, and then the main content right here on the right. This layout only appears for authenticated users. So let's take a look at app.jsx and talk about layout architecture and routing. So I'm using a React router with a pattern I call render protected. So basically for any protected route, I'm checking if the user is authenticated. If they are, I wrap the page in a main layout, which is seen right here in this main layout. If not, I redirect them back to the home page. And as you can see right here, this render protected, the main layout is the wrapper component that includes the header and the nav bar and the post modal. So every protected route goes through this render protected and automatically gets that consistent layout. And if we take a look at main layout.jsx, here's main layout. So it's pretty simple. We've got a header at the top, a main content wrapper that holds the nav bar on the left and the children on the right, then the post modal, which is hidden by default. So on the UI, the header is this top bar right here with the CodeBloggs logo, this post button, and the user menu on the right side with the account settings and logout. The nav bar is this left side right here with links to home, blogs, network, and if you're an admin, there will be an admin page that shows up. And then the main content area is where this page-specific content renders. So if you notice, the layout stays the same even if we're on different pages. That's the power of this layout wrapper pattern. I define it once and then all of the protected routes inherit it. So let's take a look at store and talk about state management. So I made a deliberate decision here to keep Redux really minimal. So if we look at the Redux store, there's only one slice, and it's the alert slice. So let's take a look at alert slice. This has 3 pieces of state. So there is a message, there is type, and there's visible. And it has 2 actions, show alert and hide alert. That's what powers the global notification system that you see in the bottom right whenever we logged in. And this happens when a user likes a post, when they comment, when they log in, when they log out. There's just a global alert system so the user knows that what they're doing is actually working. So if we take a look, I'm kind of in the way here, but I'll scoot over, and if we hit the like button, that comes up. If we do comment posted, this is a Redux dispatched alert. So let's take a look at where those alerts live in the code, which is the global alert.jsx. And this global alert component subscribes to the Redux state with the use selector. And whenever an alert is dispatched, it renders here. There's also a use effect that automatically dismisses the alert after 5 seconds. So why did I only use Redux for alerts? Because for everything else, user data, posts, comments, I'm using React's local state. The authentication state lives in app.jsx and gets passed down as props. Post data lives in the blogs and home components and gets fetched on mount. Comments live in the comments list component. I could have put all of it into Redux, but honestly it would have been overkill. Props and local state work perfectly fine with the app that we're building here, and it keeps the architecture simpler. Redux is great when you need global state that multiple disconnected components need access to, and alerts fit that perfectly. So any component can dispatch an alert from anywhere in the app. Now let's take a look at the blogs, feed, and post system. As you can see on the blogs page, it shows all posts from all users sorted by the newest first, and this lives inside of blogs.jsx. So when this component mounts, I'm fetching all of the posts and all of the comments. Once the data comes back, we normalize it with the normalize post utility, as we can see right here. I'll explain why in a second, and then we store it in local state. I'm also setting up an event listener here for a custom event called post refresh. This is how we handle cross-component communication without prop drilling. So let's take a look at the post modal. So when a user creates a new post in the post modal, after the post is successfully created, we dispatch a custom window event. Then any component that's listening for this post refresh, like blogs, home, and post detail, will refetch their data. And back in blogs.js, it's a simple pattern, and it avoids having to lift state up or pass callbacks through multiple layers. So the post modal doesn't need to know what components care about new posts. It just needs to broadcast the event, and whoever cares listens for it. And if we scroll down to the return statement, so the blog page renders a list of blog post item components. Each post is a reusable card that displays the title, the content, author initials, like button, and comments. Now if we take a look at the blog post item component, this is one of my core reusable components. So it receives post data as props along with the current user, and it renders the entire post card. And this right here in this return statement is the post card structure, and it includes the author initials, author information, their name, the post date, and the content. Then below that is the comments and the comment form. So let's take a look at the UI. So let me click this like button. And as you can see, it immediately turns purple and that global alert pops up and this count updated. So this is what's called an optimistic update. So I'm not waiting for the server to respond. I'm updating the UI instantly, and if the request fails, then we'll roll it back. So let's take a look at the like button really quickly. So this is the like button component. When you click it, I immediately update the local state with this new like status and count. Then I send the request to update the backend, and if it fails, then we'll revert the state. This just makes the app feel way more responsive. Users don't have to wait for a round trip to the server just to see their like register on the page. So now let's take a look at the comment system. Under each post, there is a comments list of all comments and a form to create a new comment. So in commentlist.jsx, this is another reusable component. So it fetches comments for a specific post on mount, passing the post ID as a prop, and then renders them as a list. So again, each comment shows the author's initials, the comment content, the author's name, and the date the comment was created. Pretty straightforward. Now let's look at the comment form.jsx. This is where the users actually type the comments. It's the input field. So when they submit, we send a post request to API/comments. If it succeeds, then we dispatch a Redux alert. As you can see, this dispatch show alert. We clear the form, and then we call on the comment created callback. That callback is passed down from comment list, and it triggers a refetch of the comments, so the new comment appears immediately. So if we take a look at the browser and add a comment to a post, and then once I hit post comment, that global alert shows up again right behind me, and the comment appears in the list. So the flow is form submission, API call, success alert, callback triggers refetch, and then new comment renders. So now let's take a look at the home page. The home page is a little bit different from blogs because it contains this user card right here. It's a personalized feed and it shows posts only created by this user. So let's take a look at home.jsx. So in home mounts, I'm fetching all posts from API posts and all comments from API comments, but then we filter them by the user ID. And we're also fetching the user stats. So we're fetching the total post, their last post date, and their initials to generate that icon that we see with their initials here. And then below that, all of the users' posts with the same blog post item component. So I'm using the blogs page, the same blog post item that I'm using on the blogs page. Same like button, same comments, all reusable components. So now let's take a look at the network page. So the network page, as you can see, displays all registered users as cards. So let's take a look at network.jsx. So on mount, we are fetching all users and all posts. Then we're using this get latest post for user function to get the user's latest post. And then we render a user card for each person, which is this return statement. And if we take a look at the user card component, so the user card displays the user's initials, their name, their location, their occupation, their status, so if they're an admin or a member. And then there's also this additional take me to post button. This is something that wasn't a requirement, but I added it because it felt a little bit more like a real website that you would use. And then when you click this button, it takes you to the full post detail view. So let's take a look at that in here. So for instance, if we wanted to see this test post, we hit take me to post and it shows us this post detail view. This is a dedicated page for single posts and to show all of its comments. The route is post ID, and I'm using the use params to grab the post ID from the URL. So let's take a look at the post detail page. In this component, we're fetching the specific post with the post ID, as we can see here, and then we render it with that same blog post item component. It's that same reusability pattern that's seen all throughout this app. So now we can take a look at the admin system and role-based access. So if you see right here on this sidebar, you'll notice that there is not an admin link showing. That's because right now I'm logged in as a regular user. If I were to log in as the admin user, then we see that admin page shows up. So let's take a look at navbar.jsx. So if you can see right here, the admin link only renders if the current user admin is equal to admin. So it's a simple role check here. And then if we look at app.jsx, in the routing logic, the admin page is protected both by authentication and by this additional role check. If you're not an admin, then you'll just redirect to home. And then if we take a look again at admin.jsx, the admin page itself has a guard as well. So if the current user isn't an admin, then it redirects you to the home page. This is two different layers of protection for that admin route. And in our current implementation, the admin page is just a placeholder. So it's got these two cards, user manager and content manager. These aren't functional yet, but the role-based access is fully wired up so that implementing this page should be relatively quick and easy. And now let's talk about the fun stuff, which is the design system and the glass morphism. So like I said in the beginning, I built this entire UI from scratch. So there's no component libraries, there's no bootstrap, everything is custom CSS, and each component and page has its own CSS file. The design is based on glass morphism. So that's that frosted glass effect that you see all over the website. So as you can see, like these cards, these hover buttons right here, this little frosted glass effect over all of the posts and the user card. It's a semi-transparent background with a blur effect. So I'm using a backdrop filter blur along with the RGBA colors for the transparency. And if we take a look at the index.css, which is our main style sheet, we're using the CodeBloggs brand color palette. So it's this Delft blue, lavender, indigo, periwinkle, dim gray, and the slate blue. So every color in the app comes from this defined color palette that we've set here. So if we take a look at blogs.css, you'll see that all of the colors are pulling from the index CSS. And again, in the UI, you can see there's little movements over all of the buttons. So this is called micro interactions, like when we hover over a button we're going to click, or whenever we hover over a page on the nav bar or on the network page, this tiny lift up action that's happening when your mouse hovers over it. These are micro interactions that are small, but they make the interface just feel more polished. And so now I want to talk about this data normalization. So the reason that I put this into effect is because, again, this is my first time collaborating on a project, and I realized the importance of making sure that the backend and the front end have the exact same structure. So halfway through this project, we realized that our schema was not the schema that was defined defined for us by the requirements. And so once we changed the schema, it completely broke the communication between the front end and the back end. And so we manually fixed as much as we could, but I implemented this normalized data util just in the event that if there's some sort of lingering post ID that is not an underscore post ID, but it's just a camel case post ID, that it would normalize the data in the middle, and that way the front end and the back end are always talking to each other. So this is what is called defensive programming. It makes the front end resilient to any back end changes. So overall, I'm pretty happy with how this turned out. The front end is well structured, the components are all reusable, the state management is minimal but effective, and the design system is consistent, the authentication flow works smoothly, and the API integration is solid. The user experience feels responsive. So if I were to continue building this out, I would probably add in pagination for the blog feed and maybe some filtering or search functionality, and we can flesh out the admin page with the actual user content and content management tools. But yeah, that is CodeBloggs. That is Module 9 front end. Thank you for watching, and I will see you on the next one.